solar panels on boats and controllers. And our guest speaker is Nigel. As you can tell from my smile, it's 100% genuine and always a pleasure. Nigel, thanks for joining us here today.
Oh, thank you, Jeff. And
Awesome.
we actually have a lot to talk about.
Yeah, we do.
There's been a raft of new technologies coming into the solar world in the last few years, and some of them as recently as last year, which have basically changed many of the prescriptions we've used for recommending solar panels on boats. So it's a really good time to be talking solar. Tom Whitehead, who's an expert on the controller side of solar panels, and actually he just wrote an article in the latest edition of the Professional Boat Builder magazine.
Oh, wow. Okay.
Which is well worth anybody that wants to get a head around solar controllers. That's the best article, best information around at the moment on solar controllers. So let me get out of the way, and I'm going to put Tom in here.
All right, let's do it. Let's have Tom chime in. Hey, Tom.
Hi, Jeff. How are you?
Hey, I'm doing good. I'm doing good. Thanks for joining us.
Oh, it's my pleasure.
Yeah, so we're going to talk about solar controllers. So we had a few talking points a little bit, and maybe I'm going to ask you some questions, steer a little bit of the conversation. Of course, the podcast, it's not, doesn't have to be too sort of regimented in terms of our approach. Let's talk about a little bit about one of the questions I get a lot asked from YouTubers and fellow boaters is, Jeff, what about PWM versus MPPT? And by the way, I should have actually go before that. Let me just pause, put context to everyone. A controller is an essential part of a solar array for everyone that's wondering. You really can't do without one. The sun might be shining that day a lot and your batteries are full and your batteries don't need more power. And so the job of the controller is to really have a brain and decide what should it do with the solar energy that it is able to utilize, right? Ultimately, it's making decisions. What should it do with the energy? Should it charge at 13 volts, 14 volts on a 12-volt battery bank? It's constantly looking at the voltage, making decisions so that your batteries are charged as fast as possible, but also not overcharged. And yes, I have seen people connect solar panels directly to batteries, and it does happen. Obviously, we all make mistakes, and that's normal. But yeah, some solar panels are 20 volts, 22 volts, 24 volts. Some panels are only 7 or 8 volts. Some panels are 35 volts. So all those voltages need to be modified and adapted so that the batteries get what they want. And so here with Tom, what we're going to be talking about next is how do you go about choosing a solar controller for your boat? So back to my question, I guess, Tom, is this dilemma that people have with PWM versus MPPT controllers. Do you want to weigh in on that a little bit and give the listeners a sense of that choice?
Absolutely. I actually wanted to touch base on what you were just previously saying about whether they need a controller at all, because I actually get that inquiry sometimes. People say, well, I need a 12-volt panel for my 12-volt batteries. And actually a fair number of installers even who are new to solar have no clue that a lot of panels are less than 12 volts too. So as far as PWM, I'm not a total expert on it, but my understanding is that stands for pulse width modulation.
Yeah, that's what I understand.
It's an earlier technology that can be efficient under certain circumstances. Essentially, because all of our charge regulators use target voltages, right? And so to hold the battery at its target voltage, once it gets there, it interrupts and does a pulse to hold it there. Yeah. And the newer MPPT controllers actually convert the DC current to AC and then back to DC again. And during that conversion process, they're able to maximize what they call the power point tracking. So it's where are we being most efficient? Where is the maximum current happening? And then through the magic of electronics, it optimizes that. So in general, like here at Ocean Planet, we don't sell any PWM controllers.
Same.
Never sold one. Now in certain, I think land-based installations, it can be a much more affordable way to do it, but I mean, the PPT controllers are coming down in price as well. So I don't see it as even a question. We only sell the MPPT, especially on boats where there's so much shading and so many possibilities that, things are going to be inefficient anyway. That we only sell the MPPT.
Yeah, and you bring a good point, Tom. Same here. We've never sold a PWM. Again, it depends, I think, on the price of your solar array, right? So if you're going with a rigid panel and you're getting away with $100 panel, it's going to be harder to spend $150 on a controller. That's hard to justify. The controller is more than the panel. But if you're going with flexible solar panels or high-end solar panels, and now your panel is, could be 2, 3, 4, 5, 6. Some panels are thousands of dollars, depending on the make and the model. Then the controller is a smaller, percentage-wise, is a smaller fraction of the overall array. And you're right. I think on land, it's definitely being used for boaters out there that are using really inexpensive, obviously, very budget-conscious, rigid solar panels. Then, yeah, maybe PWM might make sense for you because honestly, we can't judge. Some of us can't afford what we want. We do what we can. But if you are spending quite a lot of money on good, flexible, or even good rigid panels, you're going a long way. Then I always tell people, I'm not telling you what to do, but I strongly encourage you to look at NPPT. And, the efficiency difference is huge. I think it's almost, you gain it's over 20%, I think, difference in efficiency.
It can actually be as high as 30%.
Wow.
So I would even use that as a sales pitch to someone with that big glass panel. It's like, hey, you want to get 30% more power out of the panel that you already have? Switch to this controller.
We do that a lot. To be honest, there's a lot of boat builders who are still doing PWM, budget boat builders. It happens. And we tell people, you might have a 200 watt array on there, but you're only having right now, you're all with PWM. And you're right, Tom, that's a good point. Some of us as boaters have an array already. And if you want to just do more out of that array than you have, swapping the controller might be one way to instantly overnight maximize, get the rated output that you had hoped from that array from the get-go without actually doing anything else, not changing the solar panel, not changing the wiring, just simply swapping out the controller from a PWM to an MPPT. Yeah, that's a good point.
Yeah, well, so if I'm going to walk a customer through picking a controller,
tell us.
You basically start with real estate to pick out what panels you're going to use. Because on boats, the real estate is prime. It's hard to find where you're going to put the panels. So that's your first thing. And then once you end up with what panels you have, the next important consideration is the shading. So how are these panels going to be shaded? Is the boom on top of them? Is it not? Et cetera, et cetera. So our first thing that we usually recommend is one controller per panel for optimal efficiency. And then if there isn't, a big concern about shading, let's say a typical thing is like up on the flybridge of a powerboat. People are now asking me for more solar to, keep their refrigeration running while they're sitting on the mooring. Up there, where there's no shading, I would recommend putting the panels in series, right? Which will then dictate the size of controller that you use. To me, that's the next best option. If there is shading, some people recommend going to putting the panels in parallel as opposed to series, which will then change, the resulting current and voltage that's going to the controller. So that will also dictate the controller.
Yeah, and you bring a good point here. There is no, and I get this all the time. I mean, I'm talking every day. I'm talking like 10 times a day. People are like hopeful. They're asking these leading questions, and they say, can I'll just get one control for all my panels. What they're trying to do is I know we're all doing the same thing. We're trying to save money, right? Boating is an expensive hobby for all of us, regardless of our income. We're always stretching ourselves to have the best boat we can afford. So it's hard for all of us. Even some of my clients that have a lot of money, it's still a huge expense for them because proportionally they're spending a lot of money on their boat. So we all feel the same way. And what I see is they were saying, maybe I can get away with one control for all my panels. I'm like, yeah, you might. Let's say you could. But remember, that controller is sized for various factors, and you brought those variables. Like one would be, what is going to be the maximum input voltage of the panel. The other is what's going to be the maximum amperage coming in or through that controller, either from the panel to the controller, from the controller to the battery. What's the max amperage? What's the max wattage of that array? What's the and also, can you configure that controller for charging, let's say, for example, a Firefly battery or an AGM or a gel battery bank, right? Can you customize the charge profile to fit the battery you have? And then also, one error I did, and I forgot, I remember this a few years ago, didn't ask the owner if he had a 12 volt or 24 volt system. You also have to decide.
Yeah.
If you've got a 24 volt system, you've got to make sure that you get a controller. Not all controllers are able to connect to 12 and 24. Sometimes you have to buy the right controller for the voltage of your battery bank. So tons of choice.
We've been selling more solar systems for electric propulsion support as well. And there you're getting into 36 volt, 48 volt.
Right.
And again, that's a really good point. What is the voltage of the system you're dealing with? The other big hurdle or the big decision that you need to make is whether you need, on the one hand, a buck controller, what they call a buck controller, which brings like your 20 volt panel down to 14 volts, or if you need, on the other hand, a boost controller, because a lot of the mono cell panels that we sell nowadays are under 12 volts. They're only putting out, say, 9 volts or even 12 volts, which isn't enough, right? Because we're charging to 14. So that's another really important distinction. And often if you have, let's say, 3 medium to small panels, and you want each panel to have its own controller, then it has to be a boost controller.
Yeah.
And currently, there's really only one really good boost controller on the market, which is made by the Jennison Corporation. I think we have.
Yeah.
This is not a boost controller, but you can.
It looks like that.
The size of it, yeah, it's about the size of an old chalkboard eraser. To those of us who remember what a chalkboard eraser is, anyway. And the only other boost controller that we've sold is by the Western company from Italy. And the differences between those two are essentially, this one does temperature compensation by being in the same space as the battery, right? So it senses the ambient temperature around the battery. So this has to be in the battery space or like in a similar locker next to the battery. So it's about the same temperature. The Western boost controller actually runs a wire to the battery. And so you have a little more choice about where to mount it. Western also makes a really unique controller, the WM10, which does either buck or boost. So if you have a panel system that's fluctuating between being a little bit under 12 and then over, like if you have 2 panels, you hook up the WM10 and it'll do both. So that's a pretty cool option. But like we've been hounding Victron for a year or so. Like, you guys need to come out with a boost controller. And
it's so true. On my boat, when I did my solar array about 8-9 years ago, I had 3 panels that were 50 watt, Solbian 50 watts, SP 50s. And all of them were connected to two boost controllers. And I think it's essential. You brought that point up, and even all of us get sort of maybe not, hurdles, I guess surprising things. And it's often that people come back and say, I have a 12 volt battery, I want a 12 volt panel, that assumption. And I remind, and it's really important to remember that it's not that the panel is not worse because it has a lower voltage, and it's not better because it has a higher voltage. At the end of the day, there's no way that your panel will ever output what the battery needs over time, adapting as the battery gets discharged or charged. And so you have to have a controller. And the question is, are you going to get a boost because the panel voltage is lower than what you need? Or are you going to get a buck, which means you're going to bring it down, or that Western? And by the way, we've had success with that Western Marine as well. We use it sometimes, and it does make sense. It's a little bit bigger controller, not as compact.
It also has a little readout screen on it. and some people love that.
Yeah.
They can just look right at it, and they don't have to remember what the flashing lights mean. That it's reading, oh, so many watts are happening. That's another nice thing about them.
So do you want to talk a little bit? It sounds like you're pretty familiar. Can you talk a little bit about I get questions about those lights on those Jennison controllers a lot. Do you want to talk a little bit about, can you talk a little bit about those status lights on the controllers, by the way? Do you get a lot of questions about that?
I'm not a person who keeps data in my head very well. So usually when a customer calls me, I go and I open the manual and double check. But essentially, like on these Jennisons, there's this little LED light here, and it will flash at different rates. So if it's flashing really quickly, that means it's charging, but at kind of a low amperage, below where it's supposed to be. So you know it's not really doing its full thing. If it charges at a more regular, like 1 second interval, if it flashes, sorry, then you know it's charging at the bulk absorption setting. If it's solid green, that means the battery's charged and it's done. Then there are a myriad of red lights and that flash at different rates to tell you different things are bad. And then there's another one that tells you that the fuse inside the unit is blown. So it's actually quite useful, the LED.
Yeah, I agree.
And Jennison's pretty good about laying that out in the manual.
Yeah, reading the manual always. I mean, so many of us don't read the manual often enough, or we read it and we put it away and we forget. The other thing too, it's worth noting. I get this all the time. People expect solar to charge their batteries at maximum output, regardless of the state of batteries. I get this all the time. Like, oh, my solar. I'm looking at my battery monitor. I'm not charging. Why am I not putting out? I've got a huge array. Why am I not seeing 10 amps, 15 amps as I sometimes do? I'm like, are your batteries full? Yeah. I'm like, and I tell people, I'm like, well, you know what? Actually, the battery's a little bit like you. Like at one point, there's such a thing as an appetite. You can't force feed a battery a charge, and for you to see what the maximum output of your controller is, the only way to do that is to have the batteries in a clearly depleted state, some sort of discharge. And I'm not talking going from 100 to 99. I'm talking from, you probably want to be somewhere where you're going to see at least where potentially bulk, maybe 70%, know that the batteries are low enough that solar can't do everything. You want to, and then the controllers are going to do everything they can, and then they're going to be assuming again that it's relatively sunny, that it's best part of the day, that you don't have shading. That's when you're going to be able to look at the diagnostics on those LEDs, LEDs, and you're going to be able to see, okay, yeah, now I'm seeing what I thought I should see or what I saw another day, because it's going to change every day depending if your batteries are full or not.
Yeah, I think that's a really good point. And the analogy that I use the most is the reservoir analogy. So I equate a battery to a water reservoir.
Okay.
And if the water reservoir is low, then the charge sources can put the full amount of current or flow into that reservoir. And it could be your alternator, it could be your shore power charger, it could be your solar. They're all pumping water back into the reservoir. But when the reservoir gets full, that stream is going to slow down to a trickle because you can't force it in there once it's full. And sometimes that helps people because they get confused about what, I mean, and myself included, when I first started working with Bruce, I kept thinking that these charge sources were sending voltage. They were sending 14 volts, but they're not. It's the batteries at 12 and it's trying to get to 14.
Yeah.
So that's another thing that, since it took me a while to figure that out, I often explain that to customers because they often have the same misconception. It's like,
it's hard.
Electrical, you're sending current to raise the voltage to a certain target and then hold it there. And there's often that question of, hey, is my alternator fighting with the solar?
Oh yeah.
And back and forth. And sometimes I will tell people to use a breaker as their main fuse for solar, that they can then turn it off so that if they want to see the separately what's going on, turn the solar off when your batteries are discharged, fire up the engine, see what the alternator's putting in, shut that down, turn the solar back on, see what the solar's putting in, see how they act. Because they really should act completely independently until both of their voltage sensors start picking up what the battery voltage is. And then because that was the point I wanted to make, that the other great thing about the MPPT controllers is that they are mimicking what we're trying to do as modern charge controllers, is 3-stage, at least. I think Victron's up to 6 stages now, but at least 3-stage charging, right? Where you've got your bulk stage, your absorption phase, and then the float phase. It's another real advantage of having solar on your boat, is that, especially if you have lead batteries, they are never fully charged, almost ever. And so the solar can do that finishing charge for an extended period of time when, the boat's sitting out on the mooring, especially if you're not shoreside, if you're not plugged into your shore power. The typical sailor never fully charges their lead battery even if they run the alternator for, 2 hours a day. It could take 12 hours to fully finish charging that battery and keep it from sulfating. So having a nice solar system on board really helps with that finishing charge.
Totally agree.
And it's regulated. It's sending it at the proper float voltage.
It's so true. And it's, in some ways, here sometimes we have power outages, it does happen. It's not the grid failing, but windstorms,
right.
Windstorm's going to happen. Some power lines are going to go down. And so solar, even when you connect it to shore power, on my boat, I don't get to see it every day. Some boat owners get to see their boat every day. That sounds to me like paradise. But some people like me, I get to see my boat maybe sometimes, I'm missing weekend. I'll miss 2 weekends. And now it's at a dock, connected to shore power. It's got a battery charger, but it's also connected to solar panels, the batteries, via controllers. And if I lose my battery charger, the solar is going to step in and do what it can and help. And you're right, that finishing charge when you're actually cruising is the hardest thing to do, because, running an engine, to recharge your batteries at 100 amps is motivating, or 50 amps, a maximum output of the charger, bulk charging, with your alternator, you're getting a lot of juice. But running an engine and only getting 5 amps out, because now your batteries are almost at the end of the absorption cycle or in float, and you're just topping off the battery trying to get that last charge. Running the engine and getting so little out of the engine is frustrating.
Very wasteful.
And that's where solar is awesome. It does the finishing. The alternator might do a lot of the bulk and might get you like most of the way there, but then at least solar is there in the background doing its thing, completely quiet, no vibration, no smoke, no noise, and it's doing its thing in the background. And that's right, it's going to help maintain the batteries in a higher state of charge, undoing potentially what you talked about, this concept of sulfation, which is really aging for a battery. It's not being able to re-energize the battery completely as we should. I mean, the reality is, none of us are treating batteries perfectly. You can't. If you're using a battery, it's getting warm. The question is, you're trying to mitigate how much you're doing that.
Right.
That's really interesting.
I was thinking of another thing to bring up about controllers, which Victron has really pushed, and it's working really well, is using Bluetooth within the solar controllers, and also for the temperature sensing. Because it used to be that, and still with a lot of controllers, if you want to get proper temperature compensation, which incidentally, if people don't know what that is, that it's essentially, if your battery is cold, you can hit it with more current and push it to higher voltage. If your battery is hot, you want to lower that, because you can damage the battery if you're charging it too much when it's hot. So temperature compensation is actually pretty important. Used to be that even the Victron controllers had to be in that battery compartment sensing the temperature. And so now they have this little device. It's called the SmartSense, and it's glued onto the side of the battery and connected to the plus and minus. And then you network it with the handy app on your smartphone to that particular controller or any number of controllers on the boat. And the controller will receive the battery temperature from that little sending unit. So that gives you a lot of flexibility about where to mount the controllers. And it also gives you this flexibility of, just opening the app on your smartphone and seeing immediately, hey, what's my solar doing? Oh, cool. I'm getting, this many amps or, total watts. And my batteries are 60 degrees. And that's why, because I get calls from clients and they say, oh my God, the solar is pushing it to 15 volts. What's going on? I'm like, well, how cold are your batteries? Yeah. Oh, they're 55 degrees. Oh, well, that's okay. I actually had a client
all the time.
Email me the other day saying, is this okay? And I'm saying, yes, it is, because of temperature compensation.
I'm going to rehash that. I think it's a great point you bring, Tom. The temperature compensation is essential. I mean, even us humans eat differently in the wintertime than we do in the summer.
Right.
Honestly, I think batteries are so similar to people. And so you literally have an inverse correlation, right? In the wintertime, it's cold, you eat more. In the summertime, it's hot, you eat less. Batteries are the same. They actually want, when batteries are cold and you've got low temp, you're right, the voltage is going to go higher. It's going to be temperature compensated, assuming, of course, that the temperature sensor is mounted in the right place and never on top of the battery. Never, ever, because there's an air pocket there. You can put it, some of the temperature sensors can go right on the lug, because obviously that's, right. It's going to be like metal is a great conductor of heat or temperature. So the temperature of the lug, and generally we put them on the negative, not the positive. Right. That's going to be a good way. Or like you said, Tom, and it's really good point, you can put it on the side of the battery because there's no air pocket, right. And you're going to get a good temperature. And then the question would be even bigger is like, okay, well, now I got a bigger bank. Where do I put the temperature sensor on a bigger bank? And you got to figure out, and I've seen battery banks fail because the temperature sensor was put at a battery that was not really representative of what happens to the rest of the bank. So that's putting a temperature sensor is not a trivial thing. It sounds trivial, but it isn't. And you're right. Inverter chargers have been doing that for a long time. I think probably, I don't even know, 20 years. I think, I know Xantrax inverters back in the early 2000s had temperature compensation. And a lot of boaters that know enough do worry when the battery voltage on a 12-volt bag goes to 15, 15.1, 15.2. Like, oh my God, what's going on? I'm like, my batteries are being cooked. I'm like, well, hang on a second. Here in the Pacific Northwest, the water temp is 9 degrees Celsius, 10 degrees Celsius, 11 degrees Celsius in the wintertime. So it doesn't freeze, but it gets pretty cold. And batteries, all the numbers that we think in our mind, 14.4, 13.4, 12.8, 12.6, 12.2, all these sort of like different, that is all for batteries that are at 25 degrees Celsius or 77 degrees Fahrenheit. So that's basically all those numbers. What we think is normal is normal at 77 degrees Fahrenheit or 25 degrees Celsius. And as soon as the temperature differs from that, you will charge your batteries faster and not overcharge and not undercharge your batteries, because both are bad. Overcharging and undercharging are both bad. Of course, overcharging will bring a faster death, but undercharging will still be a death. It's just going to be like eating, fast food every day, every meal. Eventually, you might start, it won't feel too good after a period of time, but if you did that for a year or two, you're not going to be the same person as you started. You're just not.
So Jeff, do you think you are a lithium battery or a lead battery? What do you think? I think I'm a lead battery. But
I'm a lead battery.
Bruce is a lithium battery.
I'm a lead battery. Yeah, old school. It's okay. You know what? It's been working around for a while. I know.
It takes longer to cram the information into my brain.
Oh yeah, that's really good.
Nigel
really
probably
good.
Like Bruce is a lithium battery. He can absorb.
Oh, that's good. I never had that question asked to me before. Are you a lithium or lead? I'm like thinking, did I hear that right? Yeah. I was like, oh yeah. I was like, yeah, I'm a lead acid battery. That's what I am.
Anyway, here's the edition of ProVote. It's edition 190 for those who want to read. This is where my article about how to choose your solar controller is enclosed. And I got some pretty good feedback from that, a few questions. So anybody who wants to reference that, go ahead.
Thanks. Yeah, that's a real pro magazine. Like when I go to boat builders, I mean that's the magazine the owner has on their desk, or the general manager has on their desk. You know, the electrical manager has on their desk. Like it's
really
definitely read
helps.
by industry.
It helps keep me informed because I'm also selling or trying to sell more electric propulsion systems, and it's this magazine really helps keep me in touch with what's going on in the industry.
Also, if you found this video interesting, please subscribe. It honestly does help us to know that all this time that we're investing is actually we're reaching a lot of voters. And I want to thank all of you for watching. Thanks for spending some time with me.